This class I am going to explain about the transient analysis of RC circuit. So let me consider an RC circuit which was controlled by a switch like this. So it is an RC circuit. The value of the resistance, capacitance, switch controls the electrical supply for this RC circuit, and the voltage that we are applying here is V, and the switch was closed at t is equal to 0, and the current I of t circulates in this loop is I of t, and the voltage across this capacitor is Vc of t, and the voltage across this resistance whenever the current passes through this loop, that is Vr of t. Now in this transient analysis of RC circuit, I am going to find the values of this I of t, Vc of t, and this Vr of t. I of t is the current flowing through this capacitance. We can also call it as Ic of t. Now to analyze this transient analysis of RC circuit, first of all let us consider this circuit at t is equal to 0 minus. We know this time scale, it is 0, 0 minus, 0 plus, and this is infinity, it is minus infinity. T is equal to 0 is the instant at which the switch is on. That means the switching action is done at t is equal to 0. Just before the switching action, just after the switching action. Just before the switching action, the switch is under open position at t is equal to 0 minus. So let me draw the circuit at t is equal to 0 minus. So if I draw this circuit, it will become this open circuited, resistance and the capacitance under steady state condition from minus infinity to 0. This capacitor will act as open circuit, that means that is under steady state condition. Under steady state condition, the capacitor can be represented with open circuit. So this is R, and the capacitance value is C, okay, V. And we know that this is the current at t is equal to 0 minus, that is I of 0 minus. The voltage across this capacitance is Vc of 0 minus. We know that there is no supply for this capacitance, so Vc of 0 minus is equal to 0 volts. It will not charge us. And also initially the capacitor is assumed to be uncharged. That means initial voltage across this capacitance is 0. That is initial voltage is normally represented with V0, that is equal to 0 volts. That is Vc of 0 minus is equal to 0 volts, that is equal to V0. And we know that at t is equal to 0 plus, at t is equal to 0 plus, if you draw the circuit, it is this switch is closed here because at t is equal to 0 plus, this switch just after the switching action is done. That means the switch is closed here, so it is R, and initially the capacitor, that means at t is equal to 0 plus, a representation of the capacitance will be like this. It is the initial voltage V0, and it will act as a short circuit like this. Okay, and the current passes to this is I of 0 plus, it is V, it is R, and V0 is equal to 0 here. Just now we discussed that it is initially uncharged, 0 volts. 0 volts means it will act as a short circuit, and also the voltage across the capacitance at t is equal to 0 plus is Vc of 0 plus is equal to, we know that Vc of 0 plus is equal to Vc of 0 minus is equal to V0, that is 0 volts for this case. So initial voltage across this capacitance is 0 volts. And now you see current I of 0 plus, I of 0 plus, if you want to calculate this current, this V0 will act as this short circuit. So this current I of 0 plus is equal to this voltage divided by the resistance, so V by R. That means the capacitor can allow the sudden changes in the current, but it doesn't allow the sudden changes in the voltage. This point you need to understand. Capacitor can allow the sudden changes in current. That means I of 0 minus is equal to here is equal to 0 amperes, but here it is I of 0 plus. Just after the switching action, it is having the some value, that is V by R amperes. And t is equal to 0, the switching action is done. From 0 minus, at this 0 itself, it is able to change its current, that is at t is equal to 0, it is able to change its current from 0 amperes to V by R. It can allow the sudden changes in current. So it is at t is equal to 0, the current that is flowing through the capacitance is V by R amperes. Now for t greater than 0, let me draw the circuit. For t greater than 0 means after the switching action is done, so it will act as, this is the resistance and this is this capacitance. We can draw this capacitance for t greater than 0. This is the switching circuit. The circuit will be like this. So it is V, it is R, and this is the current, that is I of t, and this is the initial voltage V0 is equal to 0 volts. Anyway, we know this. So it is the capacitance value, so that is C, and this is the voltage across the capacitance, that is Vc of t. Now V0 is equal to 0 volts, that means this voltage source will act as a short circuit. Now let us write the KVL equation for this loop. KVL for the above circuit. So if you write it, so it is plus and minus, the current is going like this, it is plus and minus, so it is plus and minus. Now this is V plus V minus I of t into R, is plus and minus, it is also, so minus V0 minus 1 by C into integral I of t, the current flowing through this, I of t dt, that is equal to 0. The voltage across the capacitor will be from here to, if you want to find the voltage across the capacitors from here to here, that is this V0 should also be considered. Okay, so if you want to find this integration limits, it is from 0 to t actually. If you want to consider from minus infinity to t, then this V0 will also be in this integration. Okay, right. So it is 0 to t. I already explained this concept in the previous video. If you don't understand this concept, you please go through that video. Okay, next, so it is V minus I of t into R. V0 value anyway it is 0, minus 1 by C integral I of t dt, that is equal to 0. Now differentiate this equation. dV by dt, V is constant here, some 10 volts, 100 volts like that. Differentiation will give 0. So R into di of t by dt minus 1 by C, the integration and differentiation will get cancelled here, so it will become I of t, that is equal to 0. If I rewrite this equation, then it is di of t by dt. If I take minus r as a common, it is plus 1 by rc into I of t, that is equal to 0. Now it is like d plus some k into I is equal to 0. So this is k into I is equal to 0. D plus some 1 by rc here, 1 by rc into I is equal to 0. If you want to find the solution for it, I of t is equal to k into e power minus this one, divided 1 minus 1 by rc into t. So this solution is obtained from the first order differential equation concept. So I of t is equal to k into e power minus 1 by rc into t. Now, so the value of current I of t, we just calculated as I of t is equal to k into e power minus 1 by rc into t. Okay. I need to find the value of this K. So in this circuit, at t is equal to 0, the value of current I of 0, we already calculated, the I of 0 is V by R. So I am going to substitute this value here at t is equal to 0. So I of 0 is equal to V by R at t is equal to 0, K into e power minus 1 by RC into, it is into 0, e power 0, anything power 0 is 1, so K equal to V by R. So substitute the value of K in this expression, I of t, we will get I of t is equal to V by R into e power minus 1 by RC into t. So we calculated the value of this I of t. What are the things that we need to calculate in this transient analysis of RC circuit here is the current flowing through the capacitance IC of t or I of t, the voltage across the capacitance Vc of t, the voltage across the resistance Vr of t. So now I need to find the voltage across the capacitance, that is Vc of t. We know that the formula for finding the capacitance voltage, that is 1 by C into integral, the limits should be minus infinity to t for t greater than 0, IC of t or I of t into dt. Here 1 by C integral can be written as minus infinity to 0, I of t dt plus 1 by C integral 0 to t I of t dt. And this value, that means the initial voltage from minus infinity to 0, initial voltage is V0 plus 1 by C into integral 0 to t I of t dt. It is the voltage equation for t greater than 0, for t greater than 0. It is also for t greater than 0. Next, the V0 value, initially the capacitor is uncharged, this value should be 0 volts. So Vc of t is equal to, now 1 by C into integral 0 to t, just substitute this I of t expression in this equation. So I of t is equal to V by R into e power minus 1 by RC into t dt. Okay. Now V divided by RC, this is constant, we can take it out from this integration, and you integrate this e power minus 1 by RC into t with respect to t here. So it will become e power minus AX divided by minus A. So e power minus AX divided by minus A will be minus 1 by RC, and the limits are from 0 to t. So V by RC, this is constant, so we can take it out from this integration. So it will become minus RC into e power minus 1 by RC into t. If I substitute this t here, if I substitute this 0 here, minus e power 0, e power 0 it is, e power minus 1 by RC into 0, so it is e power 0. So this RC will get cancelled here, so it is minus V into e power minus 1 by RC into t minus e power 0 value is 1. Multiply this minus sign with this one, so it is 1 minus e power minus 1 by RC into t. So this is the expression for the voltage across the capacitance for t greater than 0. And here I need to define the time constant here. So the time constant tau is equal to RC for RC circuit. So you replace this RC with this tau, Vc of t is equal to V into 1 minus e power minus t divided by tau. So this is also an expression for the voltage across the capacitance, and it is okay for t greater than 0. We already defined the time constant in the last video while I explained about the RL circuit transient analysis. Now, so Vc of t, we found the value of Vc of t. Another thing that I need to calculate here is Vr of t. So Vr of t, is equal to, it is the product of current flowing through this into V is equal to I into R, current flowing through this into resistance, current is I of t, so I of t into R. So I of t, just now we calculated this I of t is equal to v by r into e power minus 1 by rc. So it is v by r into e power minus 1 by rc into t into resistance. Resistance will get cancelled here. So v into e power minus 1 by rc into t, that is vr of t, or we can also write as v into e power minus t by tau, it is vr of t. So this expression is the voltage across the resistance vr of t. Now let me draw these waveforms for vr of t and vc of t and this I of t. So we know the expressions for vc of t is vc of t is equal to v into 1 minus e power minus t by tau, and I of t is equal to, that is IC of t or I of t, the current flowing through the capacitance, is equal to v by r into e power minus t by tau, and vr of t. So if I want to draw the graphs between this current, if I want to draw this current I of t with respect to time, and now see at t is equal to 0, if I substitute t is equal to 0, e power 0 is 1 into v by r, it is v by r. So at t is equal to 0, v by I of t is, I of 0 is v by r. That means it will start from v by r, and at t is equal to infinity, e power minus infinity is 0. So it ends with 0, and at t is equal to tau, e power minus 1, that is 0.392. So that is so final 0.392 v by r. So it is 0.392 v by r. So finally this curve is exponentially decaying curve. So I can draw this curve like this. So draw this curve just by joining these lines like this, exponentially decaying curve. At t is equal to infinity, it touches to this 0 value. It is theoretically, but practically at t is equal to 5 tau time constants, it will touch us to this 0 line. So this is the curve between I of t and t. If you want to draw the curve between this vc of t and vr of t, I am taking in y axis and t in x axis. Okay. Now this vc of t is equal to, if I substitute t is equal to 0 in this equation, e power 0, 1 minus 1 is 0. So 0 into something 0. That means at t is equal to 0, the value of the capacitor voltage is 0 volts. 0 volts. At t is equal to infinity, e power minus infinity, that is 0. So 1 minus 0 is 1. So 1 into v is v. So at t is equal to infinity, it will touch us to the value of v. So at t is equal to one time constant, at t is equal to tau, the value of this vc of t is equal to v into 1 minus e power minus 1, that is equal to v into 1 minus 0.392, that is equal to v into, it is 0.632, it is a 0.396 or something, 398 I think so, it is 0.632 v. That is, it will it is having the voltage, the capacitor voltage will be 63.2 percentage of, it is 63.2 percentage of v, final voltage v, it is upper voltage v. So that is 63 point, it is 50 percentage, it is 63.2 percentage. So it is time constant, one time constant tau. So it will touches this line like this. So it is at this point is, it is 0.632. Okay. So time constant, once again we can define it as, it is the time required for the response, it is vc of t is the response to reach 63.2 percentage of its final value is v. Now at t is equal to 5 tau, the value of this vc of t is equal to, is v into 1 minus e power minus 5. The value of this e power minus 5 is 0.00 6 something like that. So it is 1 minus 0.00 is, it is 0.993 into V something, 3 into 6 something. So it is approximately V. That means at t is equal to 5 tau. After 5 tau time constants, it is almost reaches to its final value. That is, let us assume this curve will be like this. So it is 5 tau. It almost reaches to its final value, 5 tau. So this is the curve which represents this Vc of t. This Vc of t. Now let me draw this. This curve is over, I of t is over, and Vc of t is over. Let me draw this Vr of t. So this Vr of t and this I of t both are exponentially decaying functions, except the magnitudes are different here. So in I of t the magnitude will be V by R. So this magnitude is V by R. It will start from V by R. But here in this Vr of t the magnitude will be V. That means it will start from here. It starts here. It starts here, and it follows the same waveform, that followed by this I of t. So at t is equal to 5 tau, it will decreases like this. It's like this. So this is Vr of t curve. So this is how we can draw the waveforms for Vc of t, Vr of t, and I of t. Now let me expand some of the problems on this RC circuit. Problems on RC circuit. Problems on RC circuit. So first problem is this one. So this is the circuit. In this circuit, initially the switch is at position 1, and the switch is moved from position 1 to position 2 at t is equal to 0. So the switch is moved from position 1 to position 2 at t is equal to 0. So we need to find the expression for Vc of t for t greater than 0. Vc of t is what for t greater than 0. So this is what I need to find here. So let me draw the circuit. The same procedure I am going to follow here. What the procedure here is, at t is, so first you draw this circuit here. So for this problem, at t is equal to 0 minus, let me draw the circuit. So this is 100 volts voltage source, and the switch is at position 1. And now this is connected to this 5 kilo ohms resistance and the capacitance. The capacitance will act as open circuit because this circuit is under steady state condition from minus infinity to 0 minus. The switching reaction is done at t is equal to 0. Before t is equal to 0, the circuit is under steady state condition. Under steady state condition, the capacitor will act as open circuit. And here the voltage source, that is minus 50 volts, is connected here. It is 50 volts. So it is position 2, it is position 1. Now this is the capacitance value, whose value is 1 microfarad, and this is the voltage across this capacitance, that is Vc of 0 minus. Vc of 0 minus is the voltage across the capacitance. voltage across the capacitance here, Vc of 0 minus. Now what I have to find here is, I need to find the Vc of t, the voltage across the capacitance. So initially I'm going to find this Vc of 0 minus. Vc of 0 minus is equal to this voltage is equal to whatever the voltage that we applied here, the same voltage will be present here, because even if you apply the KVL for this loop, no current is flowing, so no voltage drop across this one. So this voltage is equal to this voltage. Actually this voltage is equal to this voltage plus this voltage according to the KVL. This voltage is 0 because no current is flowing through this, because it is open circuited. So this voltage is equal to this voltage. So Vc of 0 minus is equal to 100 volts. So this is Vc of 0 minus. That is equal to Vc of 0 plus, because the capacitor doesn't allow the sudden changes in voltages. So Vc of 0 minus is equal to Vc of 0 plus is equal to 100 volts. That is initial voltage is V0. Initially it charges to some voltage, that is 100 volts. Or Vc of 0 can also be written as 100 volts. So it is Vc of 0 is 100 volts. Now at t is equal to 0 plus, also you find the value of current Ic of 0 minus, or Ic of 0 minus is equal to 0 amperes. No current is flowing because it is open circuited. Now at t is equal to 0 plus, this switch is moved from position 1 to position 2 now. So it is 100 volts, it is position 1 switch. Now this switch is moved to position 2 at t is equal to 0 plus. So this is value is 50 volts, and here it is 5 k ohm, and this capacitor at t is equal to 0 plus, the representation of the capacitor will be initial voltage along with the short circuit across the capacitance, and the current that is flowing through this is, let us assume it is I of 0 plus or Ic of 0 plus, and the initial voltage across this one is V0, that is equal to 100 volts. Now let us apply this I of 0 plus. I of 0 plus is equal to, find out this I of 0 plus. So it is plus and minus, it is plus and minus, plus and minus. So minus, so to find this I of 0 plus, let us apply the KVL. Minus 50, it is minus 5 into 10 power 3, 5 kilo, into I of 0 plus minus V0, that is 100 volts, is equal to 0. I need to find I of 0 plus. So 5 into 10 power 3 into I of 0 plus is equal to minus 150. So 5 3s. So it is I of 0 plus is equal to minus 30 divided by 10 power 3, that is equal to I of 0 plus is equal to minus 30 milliamperes, minus 30 milliamperes, or minus 30 into 10 power minus 3 amperes. So I of 0 plus is nothing but I of 0 here. Why? Because the capacitor can allow the sudden changes in current. So at t is equal to 0, at the instant of switching on this supply, that is at the instant of switching action, it can allow the sudden changes in current. That means I of 0 plus is equal to I of 0, that is equal to minus 30 milliampere. So this point should write here. Next, for t greater than 0, the same circuit I am going to draw for t greater than 0 for this problem. For t greater than 0, so let us write the voltage here. It is 100 volts, and this is position 1. And next, at for t greater than 0, this switch is at position 2, and this is minus and plus, this 50 volts, and here it is 5 k ohm, and this capacitor will act as initial voltage plus capacitor. So this will be like this. So whose value of the capacitance is 1 microfarad, and the initial value of the voltage V0, that is 100 volts, and this is Vc of t. This Vc of t. Okay, and the current, let us assume the current is I of t. Now let us write the KVL equation for this. Minus it is plus, plus and minus, it is plus and minus. So first if I write this minus 50 minus 5 into 10 power 3 into I of t, it is minus V naught, that is 100, minus is 1 by C into 1 by C value is 1 microfarad, that is 1 into 10 power minus 6, 1 by C into integral. It should be from 0 to t. It should be from 0 to t. Why? Because already from minus infinity to 0 we wrote this V naught here, that is from 0 to t, and I of t dt is equal to 0. Now what I need to find here, I need to find actually this Vc of t. If I am able to find this I of t, then I can find this Vc of t is equal to 1 by C into this I of t, like this 1 by C into integral 0 to t. I can find this Vc of t if I know the expression I of t. So we try to find this I of t here. Differentiate this equation with respect to time. Minus 50, if I differentiate 0, minus 5 into 10 power 3 into di of t by dt, minus 100 is 0 for differentiate. So it is 10 power 6 into, if I bring this 10 power minus 6 to the numerator, it is 10 power 6 into I of t is equal to 0. Let us consider this equation as 1. Next it is I can write as di of t by dt. If I take minus 5 into 10 power 3 as a common, so it will become plus 10 power 3 into 10 power 10 square into 10 divided by 5 into 10 cube into I of t is equal to 0. I can rewrite this expression like this. So it is 10 power 3, 5 twos. Okay, so it is 200. So di of t by dt plus 200 into I of t is equal to 0. So now you write this d plus 200 into I of t is equal to 0. If you want to find the expression for I of t is equal to k into e power minus 200 into t for t greater than 0. And I need to find this constant, arbitrary constant k, using the initial condition, that is at t is equal to 0, the value of I of t is I of 0 is equal to k into e power minus 200 into 0. It is so here it is k into e power 0 is e power 0 is 1, so k I of 0. We already calculated the value of I of 0 here is minus 30 milliampere. So k value is minus 30 into 10 power minus 3. So this is the value of k. Substitute this value of k in this expression I of t. So I will get I of t is equal to minus 30 into 10 power minus 3 into e power minus 200 t. It is for t greater than 0. This is not what I require to calculate. I need to calculate the voltage expression Vc of t across this capacitance. So to find this Vc of t, what I need to do here is I need to find Vc of t is equal to 1 by C into integral minus infinity to t I of t dt. This is the formula for finding the voltage across the capacitance. So it is 1 by C into integral minus infinity to 0, it is I of t dt plus 1 by C into integral 0 to t I of t dt. Okay, so here it is this value is V0, initial voltage V0 plus 1 by C into integral 0 to t. I of t is this much, that is minus 30 into 10 power minus 3 into e power minus 200 t dt. So Vc of t, this is Vc of t. Now V0 value, V0 initial voltage is V0 is 100 volts. So this is 100 volts plus C value is 1 microfarad. 1 microfarad is 1 by 10 power minus 6 integral 0 to t it is this minus 30 into 10 power minus 3 into e power minus 200 t dt. So 100. So if I bring this term to the numerator, 10 power 6 into 10 power minus 3, that is 10 power 3. So it will become plus 30 into 10 power 3. If I integrate e power minus ax, so it will become e power minus ax by a. So it is, and the limits are 0 to t, and it is 100 is minus 30 by 200 into 10 into 10 square. This 100 will get cancelled. So it is, if I substitute here, it is e power, if I substitute t here, it is e power minus 200 t upper limit. If I substitute lower limit, it will become e power minus 200 into 0, that is e power 0, that is e power 0. Okay, that is 100 minus 3 by 2 is 1.5. So 1.5 into 10 square, it is 150. So it is e power minus 200 t minus 1. So if I rewrite this equation, it is 100 minus 150 into e power minus 200 t. It is minus 150 minus plus, it is plus 150. I think we did a mistake here. Here we forgot to place this minus sign here. So you see, this minus 30 into 10 power minus 3. So it is minus, and this minus will get cancelled. Here it will become plus. So it will become plus here. So it is plus 150 into e power minus 200 t. It is plus and minus, it is minus 150. So this will act as, this will become 100 minus 150. So it is minus 50 plus 150 into e power minus 200 t for t greater than 0. So this is the expression for Vc of t for this above problem. Next problem is this one. So this is an RC circuit in which we need to find the value of the expression for I of t. So I need to find the expression for I of t for t greater than 0, and the switch is closed at t is equal to 0. From this position we can understand that the switch is closed at t is equal to 0. If the direction of this switch is like this, at t is equal to 0, the switch is opened. So in this case, the switch is closed at t is equal to 0. At t is equal to 0 minus, that is just before the switching action, the switch is in open position. Just after the switching action, the switch is in closed position. The difference between this type of problem and this type of problem here is this input. This input here is DC input, and this input here is exponential input. And another problem also I will explain in this RC circuit, that is sinusoidal input. For AC circuit, how to analyze the transient analysis, I will explain in the next problem. So for this exponential input, we need to find this expression I of t in an RC circuit. So any circuit, if you want to find this any expression here, what we have to do here is this one, at t is equal to, sorry, first let me draw this circuit. Okay, okay, first it is second question. The answer for second question is this way. So at t is equal to 0 minus, let me draw the circuit for this. T is equal to 0 minus. So the switch is in open position. So this is 4 into e power minus 5t. The switch is in open position. This is 0.2 ohms, and the capacitor. So under the capacitor you place it like this. There's a capacitance and it is 1 farad, and the current that is flowing through this is I of 0 minus, that is I of 0 minus is 0 amperes, because no current is circulating in this loop, so it will become 0 amperes. And this the voltage across the capacitance, so let us assume it is VC of 0 minus is also 0 volts, since no current is applied for this capacitance, no charge, so no voltage across this capacitance, so initial voltage is 0 volts. And at t is equal to 0 plus, also the same voltage will be present at t is equal to 0 minus. Whatever the voltage at t is equal to 0 minus, same voltage will be present at t is equal to 0 plus, because it will not allow sudden changes in voltages. Capacitor will not allow sudden changes in voltages. Okay, so I am calculating the current at t is equal to 0 minus, voltage at t is equal to 0 minus, and the voltage at t is equal to 0 plus. Let me draw the this circuit at t is equal to 0 plus. T is equal to 0 plus, and this is the plus and minus. It is 4 into e power minus 5t, and the switch is closed, and it is 0.2 ohms. So now this will initially, what is the voltage across this one? 0 volts. So let me write this 0 volts, and this 0 volts is short circuited. This capacitor will act as the short circuit, and this is the current at I of 0 plus. For DC supply only it will act as a short circuit, but it is not DC supply, exponential decaying function, but we are calculating it at t is equal to 0 plus, means at t is equal to 0, 0 minus 0 plus. Switching action is done at this point. So t is equal to 0 plus means almost it is 0. That means if I place t is equal to 0 in this exponential decaying function, e power 0 is 1. So it is 4, it is plus or minus. It will act as a DC supply. So for DC supply it will be short circuited. We can write like this. So I of 0 plus, it is 0 volts, that is equal to V naught, initial voltage, just we calculated like this. So this is the representation of the capacitance at t is equal to 0 plus. Now let us write this I of 0 plus here. I of 0 plus is equal to, so 4 into e power minus 5t, 5t is 0, because at t is equal to 0 only, divided by 0.2. So e power 0 is 1. 4 by 0.2, that is 4 into 5, that is 20. So it is I of 0 plus is 20 amperes. So this is I of 0 plus, that is equal to I of 0 only. That means the capacitor can allow the sudden changes in current. So at t is equal to 0 plus, this is the current. At t is equal to 0 also, this is the current. At t is equal to 0 minus, the current is 0 amperes. Suddenly it can allow the sudden changes in the current, it can allow, capacitor can allow. So it is 20 amperes. So we calculated the initial current that is flowing through the capacitance is 20 amperes. Now let me draw the circuit for t greater than 0. For t greater than 0. So if I draw the circuit for t greater than 0, now it is exponentially function, and this circuit is closed. It is 0.2 ohms, and here it is initial voltage is 0 volts, and the capacitance we have to replace like this. So the representation of this circuit, this capacitance will be like this at t greater than, for t greater than 0, and this current is I of t, and the capacitance value is 1 farad, and the voltage across the capacitance is Vc of t. It is from minus infinity to t, the value of the capacitance, the value of the voltage Vc of t. Now let me write this KVL, apply KVL, apply KVL for this loop. then it is 4 into e power minus 5t. It is plus and minus, it is plus and minus, it is plus and minus, it is plus and minus. It is 0 volts. You need to consider this voltage. Now it is minus 0.2 into I of t minus 1 by c. C value is 1. Integral 0 we already considered here. So it is, since it is 0, we need not to consider this voltage. So it is from 0 to t. 0 to t I of t dt, that is equal to 0. So now this expression I can rewrite like this: 4 into e power minus 5t, 4 into e power minus 5t minus 0.2 into I of t minus integral 0 to t I of t dt is equal to 0. If I differentiate this equation, then I will get 4 into e power minus 5t into minus 5 with respect to time minus 0.2 into di of t by dt minus differentiation integration will get cancelled here for this. So it will become I of t is equal to 0. Okay. Now minus sign, if I take all the minus signs here, it is 4 5 20. First you write this minus 0.2 into, sorry, plus 0.2 into di of t by dt plus I of t is equal to, if I bring this term to the right side, then it will become, or okay, if I bring this term to the right side, then it will become minus 20 into e power minus 5t. Just I am rewriting this equation like this. So 0.2, so this will become di of t by dt. 1 by 0.2 is 5 into I of t, it is minus 40, sorry, 5 into 2 100 minus 100 into e power minus 5t. So this is an expression, first order differential equation it is. So in this this is like this: di by dt plus p into I, that is equal to q. So whenever this first order differential, non-homogeneous first order differential equations are there, then the solution for this type of problems here is I of t is equal to k into e power minus pt plus e power minus pt integral q into e power minus pt, sorry, e power plus pt dt. So here p value is 5 and this is the q value. Now let us substitute in this expression to get the solution I of t. I of t is equal to k into e power minus 5t plus e power minus 5t integral q value here is minus 100 into e power minus 5t, sorry, e power q value is minus 100 into e power minus 5t. Already here it is e power p value is 5, so 5t dt. So e power 5t, this 5t will get cancelled here. So k into e power minus 5t plus e power minus 5t into, it is minus 100. If I integrate this one, so it will become minus 100t, minus 100t. So substitute here k into e power minus 5t minus 100 into t into e power minus 5t. So it is I of t, and at t is, to find this arbitrary constant k, I am using the initial condition, that is at t is equal to 0, I of 0 is equal to, t is equal to 0, I of 0 is equal to, we already calculated, that is I of 0 is equal to 20 amperes, that is 20, that is equal to k into e power minus 0 is 0, 1, so 1 into k is equal to k, minus 100 into 0, 0 is equal to 0, so minus k, so value of k here is 20. Now let us substitute this value in this expression to get the solution I of t. Now this I of t is equal to 20 into e power minus 5t minus 100 into e power minus 5t t. So this is the expression for this type of for this problem. Now let me explain this problem. If you apply the AC supply for this RC circuit, then how to analyze this transient response analysis, that is I of t. So let me, the same procedure I am going to follow here. For all the problems, the procedure is same. T is equal to 0 minus, drawing the circuit, finding the currents or voltages at T is equal to 0 minus, and if there is a capacitor, then this Vc of 0 plus is equal to Vc of 0 minus is equal to V0, initial voltage. Capacitor doesn't allow the sudden changes in voltages. Next, for t greater than 0, t is equal to 0 plus also, we need to draw the this circuit, so that we can find the value of I of 0 plus and Vc of 0 plus. I of 0 plus is nothing but I of 0, because the capacitor can allow the sudden changes in current. And third step here is for t greater than 0, drawing the circuit. So for t is equal to 0 minus, this is the third question, and this is the answer for third question. T is equal to 0 minus, the switch is, let me explain this problem first. It is an RC circuit. The switch is open initially and the switch is closed at t is equal to 0. T is equal to 0, the switch is closed. T is equal to 0 minus, the switch is in open position. Now at t is equal to 0 minus, the switch is in open position. Let me write, it is 100 sin 500 t plus 45 degrees, and the switch is open. Resistance, and here it is capacitance, as it is you place the capacitance like this, and the voltage across this capacitance is Vc of 0 minus. The current that is circulating through this loop is I of 0 minus, that is equal to 0 amperes, because it is under it is open circuited, so no current will circulate through this loop. So I of 0 minus is equal to 0 amperes. Okay. Now Vc of 0 minus, no voltage will be appeared across this capacitance, because it is open circuited, no current will flow, no voltage will be across this capacitance, 0 volts. So initial voltage is 0 volts. We know that the voltage across the capacitance at t is equal to 0 plus is same as that of the voltage across the capacitor at t is equal to 0 minus, that is equal to V0, that is equal to 0 volts. So Vc of 0 is equal to 0 volts. So this is one thing that we calculated here. Next, at t is equal to 0 plus, draw the circuit. At t is equal to 0 plus, it is this one. The switch is closed here, and the capacitance, see, at t is equal to 0, the initial voltage is 0 volts, and the capacitance, so it is, this voltage here is 100 sin 45 degrees. Why? Because at t is equal to 0 plus is 0, it is 0, it is 0 plus, it is 0 minus, it is infinity. At t is equal to 0 plus, this value is 15 ohms, and it is since sine of 45, at t is equal to 0 plus is t is equal to 0 only, almost it is 0. So because I need to calculate the current at t is equal to 0. T is equal to 0 is switch is closed, t is equal to 0 plus switch is closed. So now if I substitute t is equal to 0 here, it will become sin 45, 500 into 0, sin 45, okay. And it's plus or minus, since it is constant, it will act as a DC supply. For this DC supply, for t greater than 0, this initial voltage is 0 volts, and it will act as a short circuit for the DC supply. Okay. So now it is I of 0 plus, I of 0 plus. Now this I of 0 plus is equal to this voltage divided by this 15 ohms, that is 100 into sin 45 divided by 15 ohms. So 5 3s 5 2s 20 by 3 sin 45 is root 2, so 1 by root 2, so it is 20 by root 3, sorry 3 root 2. So if I calculate this value, then I will get the value of this one is 4.71 amperes. So it is I of 0 plus or I of 0 plus is equal to I of 0, that is equal to 4.71 amperes. So it is the initial voltage, sorry initial current at t is equal to 0 or just after the switching action, 4.71 amperes. Next, for t greater than 0, for t greater than 0, then I can rewrite the circuit as apply the supply and the switch is closed, and this is the resistance. Initially there is no voltage here, so it is a voltage, and this is the capacitor. Capacitance value is, the value of the capacitance 100 microfarad, the value of the capacitance here is 100 microfarad, and the initial voltage is V0 is equal to 0 volts here, so V0 is equal to 0 volts, and the value of this resistance here is 15 ohms. This value of the source here is 100 sin 500t plus 45 degrees. Now this is the current that is circulating, that is I of t. I need to find this I of t. I need to find this I of t here, so for t greater than 0. So let us apply the KVL. Apply KVL here. If I apply KVL, then it will become 100 sin 500t plus 45. It is plus and minus, it is plus and minus, it is plus and minus, plus and minus. So it is minus 15 into I of t. It is minus V0. It is, since it is 0 volts, no need to consider. Next it is minus 1 by C. C value is 100 microfarad, 10 power minus 6 integral. The current that is flowing through this is I of t dt, that is equal to 0. Next, if I rewrite this circuit by differentiating, I need to find this I of t here. So just differentiate this one. If I differentiate sign, it will become cos. So cos of 500t plus 45 degrees into, again I need to differentiate this one, 500 minus 15 into di of t by dt. It is minus, it is 1 by 10 power minus 4, it will become 10 power 4 into I of t is equal to 0. So you rewrite this expression here by moving these terms to the right side of the equation. So it is 15 into di of t by dt plus 10 power 4 into I of t is equal to, it is 5 into 10 power 4, 5 into 10 power 4 cos of 500t plus 45 degrees. This 15, if I take as a common, so it will become di of t by dt plus is 100 into 10 square divided by 15 into I of t, so it will become 5 divided by 15 into 10 power 4 into cos of 500t plus 45 degrees. So 5 3s 5 2s, okay, 20 into 10 cube, so 2000 it is. So 2000, so di of t by dt plus 2000 divided by 3 into I of t is equal to 5 3s. So 1 by 3 into 10 power 4 cos of 500t plus 45 degrees. Now it is like this is the first order non-homogeneous differential equation. So it is like di by dt plus p into I, that is equal to q. If you want to find the solution for it, I of t is equal to k into e power minus pt plus e power minus pt into integral q into e power pt dt. This is the formula for finding the solution for this type of non-homogeneous first order differential equation. So here p value, find out the value of p. P is equal to 2000 divided by 3. That is equal to, if I substitute this p here, if I calculate this value of p, it is 666.67. This value is this much. Q is equal to, here it is 10 power 4 by 3. So 10 power 4 by 3, if I calculate it, then it will become 3333.33 into cos of 500t plus 45. So this is the value of q. Now let us substitute all these values here. If I substitute these values, these values, so I of t is equal to k into e power, p value is minus 666.67 t plus e power minus 666.67 t integral q value is 3333.33 cos of 500t plus 45 degrees into e power, p value is 666.67 t dt. And we have the formula for finding this at this type of expressions here. Okay, it is 3333. You take a common here, k into e power minus 666.67 t plus 3333.33 into e power minus 666.67 t into integral, it is e power 666.67 t into cos of 500t plus 45 degrees dt. Now, so this is the expression for I of t. I need to find this this thing here. So it is like e power ax cos of bx plus c into dx. The formula for this type of problems are e power ax divided by a square plus b square into a cos bx plus c plus b sin bx plus c. So this is the formula for finding the integration of this type of expressions. So now I of t. So this I of t, let me write this I of t is equal to k into e power minus 666.67 t plus 3333.33 into e power minus 666.67 t. So this integration, I am going to write this integration as e power a value here is 666.67 t divided by a square plus b square. A value here is 666.67 whole square, b value here is 500, so plus 500 whole square into a value is 666.67 cos of bx plus c, cos of 500t plus 45 degrees plus b value is 500 into sine of 500t plus 45 degrees. Now it is equal to k into e power minus 666.67t plus here this one will get cancelled here. If I calculate this 3300 divided by this value into this 666.67, then I will get a 3.2 into cos of 500t plus 45 degrees. This total value, if I multiply, after multiplying this one, plus if I multiply this total one with this 500, then I will get it is 2.4 sine of 500t plus 45 degrees. Okay, now this expression, to find the expression for this, to solve this one, what I am going to do here is just I am assuming that a sin pi is equal to 3.2 and a cos pi is equal to 2.4. Why I am assuming like this, you can understand after completion of this problem. So here a sin pi it is 3.2, a cos pi is equal to 2.4. So now a sin pi whole square plus a cos pi whole square, that is equal to 3.2 whole square plus 2.4 whole square. So a square, if I take common here, it is sin square 5 plus cos square 5 is equal to, it is 3.2 whole square plus 2.4 whole square. If we solve this, then we will get 16. So now it is a square is equal to 16 here. Now the value of a here is 4. So we find the value of a here. And if you want to find the value of phi here, phi is equal to tan inverse of this 3.2 divided by 2.4. How we found this one? So if I divide this one with this one, that is a sin pi divided by a cos pi is equal to 3.2 divided by 2.4. A will get cancelled. Tan phi is equal to 3.2 divided by 2.4. So phi is equal to tan inverse of 3.2 divided by 2.4. So if you find the value of this one, it will become 53.13 degrees. So this is the phi value and this is the a value. So now let us substitute, instead of this 3.2 we substitute a sin pi, instead of this 2.4 we substitute a cos pi. So this is I of t is equal to k into e power minus 666.67t plus it is a sin pi, a value is 4, sin phi value is 53.13 degrees and cos of 500t plus 45 degrees plus 2.4, sorry, this 2.4 is a cos pi, a value is 4, cos of 53.13 degrees, cos of 3.13 degrees into sine of 500t plus 45 degrees. Now it is k into e power minus 666.67t plus 4 into, so it is like sin a cos b plus cos a sin b, if I take 4 as a common. So the formula for sin a cos b plus cos a sin b is equal to sin of a plus b. This is the formula for sin of a plus b. So you substitute here sin a value here is, let us substitute here, it is 3.13 and b value here is this 500t plus 1. So it is sin 53.13 plus 500t plus 45 degrees. So now let us rewrite this expression I of t like this. I of t is equal to k into e power minus 666.67t plus 4 into sin of 500t plus 45 plus 53. It is 98.13 degrees. Okay, so this is the expression for I of t for t greater than 0. But here I am not calculating the value of k here. So to calculate the value of k, I am using the initial conditions. that is at t is equal to 0, what is the value of phi of 0? We calculated this value of phi of 0 at t is equal to 0. The value of phi of 0 here is 4.71 amperes. So let us substitute the value of phi of 0 is 4.71 amperes. So after substituting this value, what I got here is, so 4.71 is equal to k into e power 0 is 1 plus 4 into sine 500 is 0. So it is sine 98.13 degrees. So from this, 4.71 plus k plus, if I calculate this value, it will become is equal to this one is equal to 4.71 is equal to k in plus this one. If I calculate this value, it will become 3.96. So from this k value is 0.75. So after calculating the value of k, you substitute this value of k in this expression I of t. Final expression here is 0.75 into e power minus 666.67 t plus 4 sin 500 t plus 98.13. So this is the final expression for I of t for this type of problem. So I stop the this session. I will stop this session. Next class I am going to explain about the RLC circuit and the problems on RLC circuit.